Remainder theorem. The remainder theorem allows us to obtain the value of the remainder without actually dividing, which will be useful when we get to factoring. So there is going to be a purpose to knowing what the remainder is. So let's look at example 1 to learn how this works. We've got our polynomial here that's divided by x plus 1. Again, we're going to use our divisor set to 0 to solve and use -1 as our x value. Then we're going to plug -1 into the polynomial for x. So -1, every time you see an x value is going to be substituted in. Don't forget brackets, particularly around your exponents. All right, so -1 to the 4, we get 1 minus 2 times -1 minus 5 plus 2. Then we get 1 plus 2 minus 5 plus 2. When we add this together, 3 minus 5 is -2 plus 2, we're going to get a 0. So in this case, the remainder would be 0. Let's look at example 2. It's just another practice one. Find the remainder when x cubed minus 10x plus 6 is divided by x plus 4. So x would equal to -4 if we were solving for that. So plug -4 in for x and evaluate. So -64 plus 40 plus 6 equals -18. So that is going to be my remainder. Now this example says to verify using synthetic division. So I'm just going to do some synthetic division one more time, just so that you can see how we would still get a remainder of -18. So we would have 1, remember we need a placeholder for the 0x², so we need 0, -10, and 6. Bring down the 1 and start multiplying, then adding. Add that column, multiply, and you'll see that you do get the same remainder.